Number 3, list 6 indeterminate forms. So we have the quotient indeterminate forms, which is the ones we're most familiar with. 0 over 0 is undefined, as are either of the infinities, plus or minus, divided by each other. Neither of those give you enough information to determine what it is. We've got an indeterminate difference. If you have infinity minus infinity, that's indeterminate because you don't know which infinity is bigger. We've got an indeterminate product. 0 times either of the infinities is indeterminate. And then, let's see, that's 4. Technically, we only need 2 more, but I'll go ahead and list all 7 that we've talked about. And then we've got 3 indeterminate powers. 0 to the 0 is undefined. Infinity to the 0 is indeterminate. And 1 to the infinity is indeterminate. So anytime you're finding a limit and you get you do your initial substitution and you get one of these indeterminate forms, it tells you, we're going to have to do a little bit more work, possibly L'Hopital's rule, in order to find our limit. Hey, come on, focus. Stay with me here. Okay. So let's do number 4. Number 4 says define the limit as x goes to 0 of e to the 4x minus 1 minus 4x all over x squared. Okay, well, if you do a direct substitution, we get e to the 0, which is 1, minus 1, minus 0. So we get 1 minus 1 minus 0, which is 0, over, obviously 0 squared is 0. So this is indeterminate. Okay, remember you can only apply L'Hopital's rule on something that is indeterminate. If you apply L'Hopital's rule on something that's not one of these indeterminate forms, particularly one of our quotients, then you're not going to get the right thing. So take the derivative of the top, take the derivative of the bottom. So this is going to be the same thing as the limit as x goes to 0. The derivative of e to the 4x, you rewrite it and then multiply by the derivative of the power, which is 4. Derivative of 1 is 0. Derivative of 4x, negative 4x is negative 4. And then the derivative of x squared is 2x. We try direct substitution again, and we get 4 times e to the 0. So we get 4 minus 4. So we get 0 over 0 again. So let's apply L'Hopital. Again, this time I think L'Hopital is going to help because the derivative of 2x is just 2. So there's no way we're going to get an indeterminate form at this point. So the limit as x goes to 0, taking the derivative. Derivative of e to the 4x, again, is e to the 4x. And then you multiply by the derivative of the power. There's already a 4 sitting there. So when you pull down another 4 with the chain rule, we're going to get 16. Derivative of 4 is 0, and then the derivative of 2x is 2. And now when we direct substitute, we get 16 times e to the 0 over 2, which is 16 over 2, which is 8.